Hey everyone, welcome back to the channel. Today we are diving into the area of spectroscopy, a powerful technique that helps us understand the composition, structure and properties of different substances by studying how they interact with electromagnetic radiation. We will focus on two key methods, UVVisspectroscopy and infrared spectroscopy. Let's break them down. Let's start with the UVVisspectroscopy. This technique measures how much ultraviolet and visible light a substance absorbs, giving us insights into its electronic structure. When light passes through a sample, electrons can absorb specific wavelengths and jump to higher energy levels. This is known as an electronic transition. In molecules like 1,3-butadiene and 1,3,5-hexatriene, we see pi to pi star transitions where electrons in pi bonds absorb energy, helping us study conjugation in these systems. The amount of light absorbed is directly related to the concentration of the absorbing species in the sample. This relationship is described by BeerLambert's law, which can be written as A is equal to epsilon CL, where A is the absorbance, epsilon is the molar absorptivity, C is the concentration, and L is the path length of the sample. This law is incredibly useful for determining the concentration of solutes in a solution. So what can we do with the UVVisspectroscopy? Quantitative analysis. It's perfect for measuring the concentration of solutes in solutions. Molecular structure. We can identify functional groups and electronic transitions in molecules. Reaction kinetics. By tracking changes in absorbance over time, we can study how fast reactions are happening. For instance, molecules like 1,3-butadiene and 1,3,5-hexatriene show characteristic UV absorption bands due to pi to pi star transitions, which helps us understand how conjugation affects their behavior. Now let's move on to infrared spectroscopy. This technique looks at how molecules absorb infrared radiation, causing them to vibrate in specific ways. These vibrations give us important clues about the molecule structure. Molecules vibrate when they absorb infrared light, and these vibrations can either be stretching or bending of bonds. Stretching means the bond length changes. Bending refers to changes in bond angles. We can look at two common molecules, CO2 and H2O. In CO2, we see symmetric stretch around 2349 centimeter inverse. Asymmetric stretch at 667 centimeter inverse, and the bending vibrations around 1388 centimeter inverse. For H2O, we have OH stretching between 3200 to 3600 centimeter inverse. And bending, which is scissoring at 1640 centimeter inverse. Infrared is also excellent for detecting hydrogen bonding. Intermolecular hydrogen bonding leads to the broadening and shifting of the OH stretching bands, while intramolecular hydrogen bonding causes specific changes in the intensity and position of these bands. This helps us identify how molecules are interacting with one another. Now, what can we do with the IRSpectroscopy? Functional group identification. We can pinpoint specific functional groups based on their characteristic absorption bands. Molecular structure. It helps us understand how molecules are shaped and how they interact with each other. Quantitative analysis. We can measure the concentration of functional groups in a sample. And there you have it. A quick look at UVVis and infrared spectroscopy. Both techniques are powerful tools for exploring the structure and behavior of molecules, whether it's through electronic transitions or molecular vibrations. These methods are widely used in chemistry, biology, and material science to understand everything from simple compounds to complex biological systems. If you found this video helpful, be sure to like, share, and subscribe for more quick reference contents. Thanks for watching, and I will see you in the next video.